overall presentation is all about the different P's that you will going to face in your entire engineering career. So your journey will start with project to prototype, and if you want to become an entrepreneur, then you can convert your prototype into the product. So it's an entire visual system that you can going to learn in this 45 minutes of presentation. So yeah, so that's about me. Please go ahead, Revti.
Yeah. Hi guys, my name is Revati. I am a pass out of 2018 from the Department of Electronics at BIT, and currently I'm pursuing my master's in robotics degree at the University of Maryland. And this is my second year here. And apart from that, I started working with GreyRobotics as a co-founder from January 2018 since its inception. Apart from that, as a part of my summer work, me and Kunal both are associated with a startup here in the United States, and we are working with it in the product development field. So, yeah, this is about our journey, how we moved from projects and are working with our products right now in our startup. So, we're excited to share our experience. I hope you guys are too. So, let's start with the presentation. Okay, so when we talk about ideating our projects, so we basically have so many components in our mind, so many things in our mind. It can range from team building, working with problem statements, brainstorming a project, or creating a budget for a project, or working with the technical aspect, exploring all the resources in hand, documenting our project. So we're going to talk about all our experiences, how we went through this, and how we dealt with these concerns, and how we proceeded with our career. So when we talk about team building, so whom do I choose while making up a team? In for the project, be it a mini project, be it a final year project, everything. So in our view, so we all know that we all are from the engineering background. So we all are techies, of course. So we all have a brief as I mean, we all have the knowledge or background required to build any technical project. But along with the technical aspect in the team, we feel that a leader is also very important. So someone who manages all the like all the aspects of a project or a team is like one of the most important roles of a manager. Next is someone who can document a project very well, and like carry the team in that direction. So a team should be a diverse one where every person knows what kind of role he or she is playing, and this should be pretty voluntary. So in my view, like from personal experience, team building is one of the most crucial aspects before you start a project. So a very well known company called Boston Dynamics here in United States follows this like approach of having even like very artistic people on the team. This helps them create beautiful products. So just a simple example. So this is how a team should be. We next go to problem statement, like what do I choose as a project. So any engineering student, what would the engineering student do as soon as the professor announces in class, okay, we have to make you guys have to work on a project. So the first thing we do is go to Google and be like, okay, engineering final year project topics, engineering uh, project samples or project ideas. This is what we do. So this is high time where you need to shift from Googling these statements to having real time engineering, like platforms such as Google Scholar and stuff like that to work on your projects. Also, I would say that projects should always be very close to real time needs of the society. That is what I mean. I guess that is what the human race is expecting from engineers right now, to work in that domain where the needs of the society are served. So first, try to make your problem statement pretty realistic, pretty close to the society, and next use like such platforms to like platforms like Google Scholar to validate your ideas or get more inspiration on your ideas. Yeah, so that's about problem statement. Next, brainstorming. So the image has a like a lot of cluttered words, but few highlighted is what I want you all to focus on. So the first one is never ever fall in love with your first good idea. Never restrict yourself to your first good idea. You have much more than that. You can still keep brainstorming and think about more better ideas. There's never a stop unless you have a hard deadline. Okay, this is it. I need to stop here and continue on this particular idea. So use your entire brain to just get the best out of it, because after this you'd never go back and think whether this idea was good or bad. You just start implementing it. Second is having many alternatives. So what happens is when we have a problem statement, we know that this is the solution, but there are different ways to approach to that solution. That means, yeah, the problem can have various solutions. So try to at least glance to those alternatives, embrace all the cousins of your particular solution, and then give yourself a choice to choose the best amongst all of these. Next, I would like to talk about like six thinking hats. Okay, so make all of your team members sit and brainstorm. One alone person can never do any good. A single person brainstorming can never work out for the team. When it's a team project, always make sure that you sit with your entire team. You leverage the diversity I just spoke earlier. Use all everyone's ideas and everyone's thought process, and you're definitely gonna get a solid proof idea. Next is don't mitigate, mitigate your tunnel vision. That means reduce. Try not to be very restrictive in your imagination. Have lateral thinking techniques, have parallel thinking, so that everyone has one kind of solution and you get a choice to pick up the best one. So yeah, brainstorming plays a very important role. Next, black box. Okay, not some black box which we see in, I mean, the airplanes, but something on the very same lines is that when we know, okay, keep all the technical things aside, keep all the circuits or all the hardware you're going to put in your project aside, put it in a black box, and just think that what kind of input you need to, like, have a specified output for your problem statement. Like if you know that you want to make a car drive on the road, understand what kind of inputs you need. You first of all need a real environment. You need the roads, you need the vehicle, you need a driver, you need, there are various components to it. So put your problem statement in a black box, understand what kind of inputs you require and what kind of outputs you're going to get from it. So this is the concept of black box I wanted you all to understand. Okay, next is budgeting your project. Very important, very important. As students, you just cannot have flow of monetary flow in your project. You have to be very smart to choose or to budget down every step of your project, right from your first testing, your R&D, to your prototype, to your actual project, to even your black book, or even your other things, other requirements. Everything should be managed pretty well. So budgeting is a very important point. Then go on and explore your resources. Like if you know that you're going to design some PCBs for your project, make sure that you know the software pretty well. You study the software. You know like uh, make yourself ready to work on it. And this is not only at the individual level. The entire team should be aware of what is going on and what all is required. So yeah, start exploring all your resources you have in hand or you need to use in your project. Next is, of course, we are engineers. Start going technical, build your project, build your circuits, be it breadboard, be it PCB, anything. Just start building your project and go into the technical details, and then document your project. So documentation, if you see, it's gonna come a lot of times in my further slides as well. But this is one of the most important parts I feel is, I mean, documentation is a must, and correct documentation is a must. So at this stage, documentation will include your budgeting, your team roles, your technicalities, your timelines, and stuff like that. We'll see further how documentation changes when you change the stage of your project. So now this project is done. Now we shift to building our prototype. So very restrictive to hardware projects, but I guess this works for software projects as well. That when you create a user interface, it's also a prototype where someone is going to use it. So I explicitly discuss this domain in three fields, like building your prototype, testing your prototype, and then finally deploying your prototype. So when we talk about building a prototype, the first at most thing is do your homework very thoroughly. Go back to your basics and study all your basics. A very simple example, if your project has few sensors, few motors, few power lines, go down, see how motors work, see what kind of motors are the best. Even if it is a small component like a transistor, know its use, why it is used over there. Even if you have not embedded that transistor over there, still make sure why it is there in that module or that particular circuit you're using. So I would like to share a very a personal experience from the department when I was in my final year and I was having my project review, final project review, and I had a panel in front of me, and one of my professors very explicitly asked me, "Okay, Revati, why this motor? Why are you using this?" So I didn't have a very solid answer, to which I got fired, and I was asked to go back and like revise my basics. So that's what our professors also emphasize. Always be very clear with your basics and know why this is over here. So next would be modular testing. So modular testing is basically to avoid blowing up your entire project. So have a power circuit separate, have a sensor circuit separate, have sensors tested separately, have other circuits, small circuits tested separately. This modular testing will help you study the project in a better way and also explain it in a better way. So you know why exactly this module is used, and without this module, what the project would be like, and with this module, what are the advantages. So yeah, modular testing is one of the parts. Next would be documenting your work. Now, at this stage, documentation merely means actually documenting your basic ideas, your basic knowledge about your field or the field of the project, your testing results, your modular testing results. So documentation not always means that you need to have the end results. So when a professor say that, okay, review one, review two, document your project, mini project, document it in two phases. That means modular testing should also be documented to a good level. So yeah, documenting your work over here means basic documentation with the modular testing. Next, we go to testing, actually testing up our system. So now just stick up everything together, put a physical structure, embed your electronics, your hardware, your software, make it look like a prototype, and yeah, that is sticking up everything together. Now create a testing world. So as I gave you example of a car, maybe you won't put your first prototype on the road. You might just put it in the veranda or inside the campus or some open space which is safe and secured, which does not have all the real world like all the real world components, but yeah, creating your own testing world. So what this testing world will do is give you a very close exposure to what the real world scenario would be. This gives you a scope for improvement. So at this particular stage, you can definitely work on increasing the efficiency of your project and trying to understand what exactly can be reduced, or what kind of efficiency can be brought into the project. This is a stage where you can definitely cut down on cost, remove unwanted like components, or remove unwanted modules, and try to improvise on your system. Okay, so the final stage is deployment. Here we just push our last prototype into the real world. So now the car is running on the road, maybe not outside on the highway, but like inside the campus or on a real road with real world situations, like following signals or having human interventions or something like that. Then comes presentation. So I personally feel presentation is a very important field, a very important part of your project, because you are convinced, you have been working on this project for 6 months, but when someone sits in front of you and you have to show them your project, it's very important to put the right impression or put your project in a very correct way. So simple most common parts of our presentation is explaining or discussing our idea, mentioning our approach or discussing our approach, and showing the scope of the project, the future scope of the project. But another important aspect I feel is discussing your wrong results as well. So when you're prototyping, you come across so many results, so many test results. Using a different kind of battery gives a different result to the motors. Using another rating of a battery gives a different kind of result to the motors. So mention all of these in your presentation. Let people know how many domains you have touched, how many things you have tried out, and how did you reach over here. Talk about how you improvised on your prototypes. Talk about how why this thing was not good for your project and this thing worked out for your project. Show them everything that you have tried till now. This will leave a very good like impression on the person you're talking to, and this really helps in the long run because you get used to this habit of having all kinds of results on your plate and not only the successful ones. So this is a very good learning approach, like, yeah, just an advice. Then last, document your efforts. That is very important. Everyone documents their results. Also document your efforts. When I talk about efforts, it means what the team has done, what every team member has played, what kind of role he or she has played, and include your professors, include your faculty members, include all your mentors, guides, experiences, and how we have got through these 6 months or 1 year of project. And yeah, that's what I basically mean of efforts. And then of course we all document our results, do that, and finish off a submission. So that's what my view of project and prototype was. I would now ask Kunal to take over and talk more about how you take
Okay.
your prototypes to product. Yeah.
Okay. Hello, everyone, once again. So, I would like to continue this session forward. So, as of now, you've seen all the stages, and all those are enough for engineering project. But if you want to go one step further, if you want to convert your project into the product, then these are the following things that you have to follow. So these are the overall points: drilling, market, and analysis. We can take a deeper look into the next couple of slides. Can you change the slide? So this is the first step that you have to do. So once you're done with the project, yeah, you'll get good marks and everything. But if you plan for something big, first thing that you have to do is that you have to choose industrial grade components. So in this slide, you can see that on the left hand side, you see a HC-SR04 ultrasonic sensor, which is used to excuse me, which is used to detect the proximity of an obstacle, proximity sensor. But it's good for like project for a demonstration. But if you are planning to design a real world application, then you have to go to the industrial grade sensors. And on the right hand side, that is LV Max sensor, which cost like more than 5 times than the normal sensor. And it has more accuracy, precision, sensitivity, repeatability, so that you can use the sensor in your application, and it will give you a same reading after thousands or like 1 lakh iterations. So these are the industrial grading that you have to decide exactly what kind of things that you have to use. The next one is that uh, exactly how much space your project is occupying. It's your footprint. So if you are using a THT components like uh, through whole components, then that occupies a more space. But if you want to make a product, yeah, and you have to reduce that space. So instead of that, you can use SMD components, which are more cheaper and which occupy a very less footprint. And so in this way, you can reduce your size of your product. And along with the size, you have to think for a power, because power play a big role. So you have to use a minimum power in order to design your product. So these are the couple of things that you have to work on. Next slide. So the third thing that I would like to mention is that we all did our engineering project, but we have to think one thing: we have to enclose our entire project prototype. So what you can do is that you can purchase ready-made enclosure, or else you can print your own encoder with the 3D printing. It's not that expensive. It's very cheaper, so that you can build your own custom case and you can print it with like less than 1,000 rupees. But if you want to reduce your price for your products, then you can buy your regular enclosure. It's not that expensive. that thing you can do. And there are different types of enclosures, if you are aware. So I'd like to mention a few things, like if you are making some project which is used in inside of water, or different kind of specific application. So on the market, there are different enclosures available which follows some standards like IPs. So there are enclosures which follows the IP65, so which will provide your water resistance facility, so that you can put your entire circuit into that enclosure. It will be water resistance, and you can put that everything in a sea or ocean anywhere, whatever your application will be. So these are the different type of enclosures which are available that you have to follow. But enclosing your entire system is very important. Next slide. Yeah, so once you're done with that, once you follow all these last steps, the main thing is that you have to do the robust testing. Finally, your project is ready, and what you have to do is that you have to take a test bench. So in that test bench, you have to keep your circuit on, keep it on, and keep it running for like next 25, 30 days or 7 days, 8 days, and you just have to monitor exactly how your circuit is behaving. And you have to provide some different parameters if possible. So first parameters, you can provide a temperature, so that you can keep your circuit running in cold temperature and in hotter temperature. And you have to check exactly how your circuit is behaving, because few circuits follows some like NTC or PTC characteristics, so that you have to manipulate everything on the basis of that. So you have to take care of all these things, temperature characteristics. Second one is pressure. I don't think it's possible in college level, but still you can check the pressure characteristics and how it is affecting with respect to the temperature and other parameters. Third one is a vibration. So I think like a couple of colleges have some vibrating machines in chemistry or physics lab. So you can use that in order to take one like 24 hours testing of your project, and you'll get some good results out of that. So you can check it like how reliable your circuit is and how effective your circuit is. And third one is EMF. EMF is not possible. It really required in higher power application. So once you get all this data out of all the graph of 24 hours or 48 hours, what you have to do is that you have to analyze it. So exactly which are the things where our circuit is not running or it is giving some faulty result. So on the basis of that, you have to. So if you're designing something in electronics, then you have to go to the control theory, and you have to change the basic things like poles or zeros on the basis of RC circuit or LC circuit. On depending on that, your circuit will behave in a proper way, exactly what you expected way, not a proper way, expected way. So these are the things that you have to do in this specific analyzation stage. You have to analyze the entire data what you have generated in like last 7 days, 8 days. That is the main stage of your product development. Go next. So these are the more technical things that you have to work, and there are a few things that you have to work. First one is market research. So exactly whatever thing that you are developing, you have to do the market research. You have to see exactly what are the similar kind of products or similar kind of circuits are available and how people are working on that circuit. You have to do the entire robust research in this specific domain, so that you will get a glimpse exactly what you have to do and what thing that you have to add extra into your project. So these are the things that you have to follow in your entire thing. So finally, your prototyping stage is complete. So finally, I have to enter into the next stage. Next slide, please. So finally, we are entering into the product stage. So so at this point of time where your product is ready, you have some everything data and everything, and you correct your data. You corrected your project with respect to your data, your everything. So finally, what you have to do is that you have to think for aesthetics. So you have to make it like more beautiful. Next slide, please. Yeah, you have to make it like more and more beautiful. So if somebody wants to buy your project, your product, then he will definitely see exactly how your product is looking. And there are certain things that you have to follow. It's not exactly follow, but people follow. Like if you are making some project with respect to renewable energy or any kind of solar kind of thing, then people usually use some yellow, green, and all these kind of colors. But if it is industrial grade, then people usually use black, gray, or white colors. So all these kind of things that you have to follow it, and it's pretty basic. You do not need any kind of rocket science for that. So I'd like to give you a good example of this one of my favorite project, that is project of Michigan. That is what I was following for from like last 4 years, 4 to 5 years. So it's so on the on the right hand side. So it started with the right hand side project, that is project Atrias. It was a pretty basic, and it has a two legs kind of robot. And after that, they design a next system, which is a Cassie, which is in between the middle one, GreyRobot. So they remove all the unwanted things, what they do not want, and they build everything from from all the result what they had received from this first project, first prototype. So these are the things that you have to think like exactly how you can improvise your design throughout the time. And the last one, that is a project Digit. That the last one, the green one. And as you can see that the first one is not that beautiful, but the last one is more and more beautiful. So these are the things that you have to follow throughout the project timeline. Next slide, please. Yes. So once you're done with this, your aesthetics and all that kind of thing, then you have to think for like documentation work. If your project is electronic circuit or like electronic sensors, then you have to make a data sheet, user manuals for that. But if it is a consumer product or any kind of thing, then you have to make other technical documentation, that is user documentation for that specific product. And if you have really good skills and if you make something unique, then you have to take a patent of that project, which is not required in usually in general engineering cases. But if you should have this information, like if you're planning to do something really big, then these are the things that you really take care of. Next slide, please. Yeah. So once you're done with your project, your documentation, your product, everything, so final stage is to launch your project, launch your product. So there are different things, different online these online websites which you can use and which are free of cost. You don't have to pay single rupees for that. You can make a Facebook page for that, or else Instagram account, or else Facebook account, Twitter, Google, or LinkedIn. You can make a single account with some product name or like any name, and you can launch your product on that account. So what is launching? Launching is the thing, but take out a good pictures. That is what my definition is for launching. You take out a good pictures. You have to edit it. You have to make it more beautiful. You have to write down some good content about your project, which is more attractive. You have to integrate everything, make a different package, and just launch it through the Instagram post. And there are different certain parameters that you have to follow on this all these social networks. So if you are planning to launch your product, and if you select a time and date, so in the evening time, so in the evening time, it's not good time for product launching, because all the people who will follow you or who is already following you, they are already tired and they don't have that much sense to exactly grasp exactly what you are sending. But if you send the same post in the morning time or afternoon time, which is like breakfast time, let's say a 10 to 9, 9 or 10, that will be a more effective for their entire week or for entire day. So if you selected something like Monday, Tuesday in a morning time, that will be more beneficial. So these are the small things that you engineers can follow. It's not you have to do something big, some bigger things. You have to hire somebody else for launching and all that stuff. It's pretty basic thing. Next slide, please. I think it's enough for like product development. These are the only things that you have to know for product. That's it. So I will next slide, please.
Yeah. So just to add on what Kunal said right now, even I was shocked when he used to mention all these thoughts on when and how we should publicize our product or launch our product. But yeah, this strategy does work at a very grassroots level as well. And I mean, we have seen these results work. So yeah, do
Yeah,
try it out if you get
because it's a basic mentality that in the, every morning we are very fresh, and if we open our Instagram, our attention is more into that post. So if we exactly attack on that specific time on the customer's head, then it is more effective, and it will definitely ultimately increase in your sales and your marketing and all this kind of things. These are the small things that you have to notice. And there are one more thing. If everybody knows that we have to use a specific color scheme. If you use a more brighter color, then people used to attract on that specific product of that specific image. But if you use some dull color, like very dull shades, not there's no light, then it's not that attractive. So these are the small things that you have to notice, and you have to take attention from the people, and you have to generate a traffic. That's the first thing that you have to do. And you can start at this stage as well. Like if you are in second year or third year, you can make some Instagram page. You can post some random content, some technical content. If you get some like 1,000 or 2,000 followers, and after that you launch your product, so that your 1,000 followers are you're already your followers. And then at this way you can extend your traffic. So that is what you can do. It's not a big deal to do for like all the engineers nowadays. Next slide, please.
Exploit the social media. It's a good way.
Right, right,
Yeah,
right, right.
go
So
ahead.
finally, these are the three P's that we have covered. That is, we started with project that everybody do in engineering. Next one is prototype. Convert your project into the prototype. Third one is the product. Exactly what you have to do in order to do something in industries, or you have to do something in business. So this is an entire new thing that I would like to introduce. And if you want to become an entrepreneur, if you want to start your own business, then you have to follow all these small things. It's not that difficult. You just have to follow, and you just have to think. So the first thing I would like to mention is on the left hand side. Uh, yeah, let's see this one. So this one is stands for like value of proposition. It's very bigger term in the engineering on in the entrepreneurship domain. So exactly value of proposition stands for whatever product that you had developed, what is the value of that product in the market. So if you develop a mobile phone, you can consider value like 10,000 rupees, but there are mobile phones which sells for like 1 lakh rupees. So exactly what level of value that you have created with your hand, with your engineering skills, with your 4 years of degree, exactly what you did. So these are the things that you have to really think exactly what value you have created and how many people will use it. You really have to think, like if you want to become an entrepreneur, you have to think in that perspective, exactly what value you have created. Second, the most important thing. First one is value of proposition. Second is lower down one, left one.
Yeah,
This one. This one is exactly what should be the pricing for your product. If you put your price like very high, excuse me, very high, then people will not buy your product. But if you keep it very less, then it's very it will create a doubt. Like if it is selling for like very cheaper rate, then what is the use of this product? So you have to decide all these factors, exactly what price you have to select, and what should be your segment, and what things you are giving to the customers. Because whatever value that you are getting from that product, so that is the trust that people, that customer pay to you. These are the things that you have to follow. The next one is sales. Sales is the heart of all the businesses, because if you don't know how to do the sales, then it's very difficult. It's very basic. It's not that difficult. First one is B2B. Second one is B2C. So what you have to do is that first one is business to business. Let's say so that is what we have followed. Actually, we followed the both things. First one is uh, so I'll give you a broader perspective for the sales. So as you're an engineer, what you have to do is that there are a couple of open opportunities that you can gain from internet. So there are websites like Amazon.in, eBay, Snapdeal, Flipkart. All these people, all these giants has a facility to create your own store on their website. Just it's like AmazonSeller.com. You have to open your account, and you have to list down your product, exactly how many quantities you have to list down, what will be the price, what this and that. You have to do all this kind of stuff. And finally, within like 2 or 3 days, your small store on Amazon will be launched. It's not that big, and it's free of cost. You don't have to pay any rental cost or any kind of thing. But Amazon has a policy that if you are selling something for like 100 rupees, then 8 rupees will be taken by Amazon, then 12 rupees will be charged for like courier cost, like because they will come to your home to pick your product, and they will send it to the customer. It's that easy. You don't have to pay for like courier or for anything. That is the second thing. And third thing is the basic taxation, GST. You have to pay like 18%. So out of 60 rupees, what you have to do and how you fit your entire business into that 60, including profit, including all the everything, whatever your expenses are. These are the things that you have to think for. Like if you want to become an entrepreneur, you have to think in that perspective. How you fit your business, how will you fit, and how will you set your final cost on Amazon. These are the things that come under the sale. And second one is B2C, that is business to customers. So business to customers directly. If you have 1,000 followers, if you launch your product, and if somebody out of 1,000, let's say, or 10 or 100 people ask you, yeah, exactly what is this? Yeah, I want to know more. Please send me good documentation. And after doing that, if you get like 5 orders out of that, after getting that 5 orders, then it's like directly customers. You don't have anybody in between Amazon or anybody else. So your profit will be more. It's not like you don't have to pay like any kind of fees or something. You just have to pay for like courier. So these are the things that matters a lot, and it's not that difficult. It's very easy. Okay. So the next is very 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 important part, and that is my favorite. That is supply chain. So every company has a supply chain, and if you think like entrepreneur, then you have to design your own supply chain. So supply chain, it's not a big thing. It's very easy, and it's very 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 interesting thing. What is I mean, if you are designing if you're building any product, your product will need some like raw materials. If you are making any kind of circuit or sensors or any kind of electronic circuit, you will need a components. So your first node in supply chain will be the Lamington Road market, or a vendor, or Visa, or Gala, or anybody else. So these are the people which provide your basic components. That is your first node of supply chain. Second one is that if you're designing your circuit, then you will need a manufacturer. Manufacturer will be any vendor from any part of India, so that you'll just quote them, you'll get some good price, and you'll just order to that vendor. That is your second node. If you plan to solder by yourself, then there is no node. But if you plan to give it to somebody machine soldering, or any third party soldering, then that is your third node. Fourth node will be yourself, that you will do everything, packaging and switching and everything. And fifth thing will be Amazon. So these are the different nodes that you have to think like, yeah, this is the node I have to take a follow up. This is a node that I have to take a follow up. And every node required money. Let's say your component cost will be 1,000 rupees. Then your PCB cost will like 3,000 rupees. Your soldering cost will be 500 rupees. Then everything is transportation cost will be a 500,000 rupees. So these are the different costs that you have to add into your business. So this is how all the business is running nowadays. And if you're entrepreneur, you have to think like, yeah, this is a thing where I'm spending more, but I have to reduce it. Then I have to invest somebody else. I'll give you a simple example. Let's say if you design any kind of circuits, if you want to manufacture any circuit from third party. So in India, what we did is that we send our circuit design to more than 10 vendors, and we get a quotation from 10 vendors exactly. So for a same circuit, we received a different rates. So first rate was, yeah, 100 pieces for like 1,500 rupees. Second one is that same 100 pieces for like 5,000 rupees. So third thing is that 100 pieces for like 10,000 rupees. Then we were curious exactly what is happening, why the cost and rate is exactly going up and down. Then we find out that the person who is selling the 100 pieces for like 1,500 rupees, he is giving the PCBs in like 60 days. And the one who is giving the printed circuit boards for like 10,000 rupees, he is giving within 3 days. So it's a part, or it's a role of entrepreneur to decide exactly what you want. You want cheaper rate, or you want your circuit very immediately. Then you have to balance that bridge between these different supply chains. So that is the main task of supply chain manager. But in your case, you are the supply chain. Then you just have to think. It's not that difficult. You just have to talk. You have to make phone calls. Yeah, let's see. You can talk. Can I get it in more cheaper way? You can negotiate. But this is the overall idea of supply chain. The next one is the marketing. Oh no no no. Oh yeah, that's packaging. So packaging is very big skill. because if you can see that if anybody has any product from like Apple, they model their packaging such a way that, so first you have to open your first box, then you have to open the thermocol, then there is one more bracket, then there is the iPhone. So these are the different level of curiosities that these people are creating in our mind, and this is how they penetrate into our brain. So these are the skills of packaging, and you just have to know the basic skills, like exactly what are these things, and how it is affecting. You can do the same thing with a simple box. And what we did is that we took a simple plastic packet, we put our sensor into that, we put our product into that packet, and then we purchased one like simple corrugated box, and we wrap up with a bubble wrap. So that unwrapping the bubble wrap, opening the box, and opening that small packet and get your product. So these are the small things are very important in the packaging industry. So these are the small key factors that you have to follow, and it's not that big. You just observe. If you purchase a new phone, just let's see how it is packaging, how they perform a packaging. So these are the things that you have to follow in the packaging. The next one is the marketing. So for marketing, as I said, you have a lot of mediums. You have Facebook, you have YouTube, you have Instagram. You just have to keep posting, and just make as follower as you can and make some traffic. And it has to be free. Don't no need to do like paid publicity or something like that. It has to be a free, and you just keep posting and generate traffic. That's it. That is what you have to do, and it's free. You don't have to pay any money for that, for all these kind of things. And the last one is planning. You have to do like whatever I mentioned. That is what you have to write it down onto a white paper. You have to use a lot of white papers and write it down exactly what you want and what you have to do, and how much thing that you have completed. So just do that thing. These are the overall canvas of entrepreneurship. And if you and it's not that difficult, because people has really dogma that they think business is very difficult. The business require a lot of experience, business require a lot of money. It's not that difficult. You just have to follow a simple thing, simple process, and you will be entrepreneur, and you can make money out of that. So once you follow all these steps, and if you spend like if you speed up your business, now it's time to raise your business. It's time to grow your business. So there are a lot of things that you can do for growing your business, and which is the next stage, which is come after like 2 years, 3 years, depend like exactly whenever you want that. So the first is most important thing is that find out the investors. So if you have some good sales, if you have some good customers, if you sell like more than 100 products, then you have some confidence. Yeah, this is what we did, and you will know that yeah, I have the potential to boost this product to some A level to B. Then you have to go to the investor and just ask for money. Yeah, this is my product. I did this. This is my customers. These are my regular customers. These are not regular customers. This is what we did. This is my Instagram. This is Facebook, and all that thing you have to show. You have to make the confidence that yeah, I'm capable of running this business. Then he will invest onto your product and all that kind of thing. That is the first way. Second way is that you can sell your product. If you are making some electronic product, then you can sell it to like bigger giants like Siemens or L&T or all these kind of people that you will have to sell your idea, and then they will give you some royalty or one-time money or any kind of thing. And the third method that is what we followed, and that is the most successful method, and it's very amazing. You have to do the bootstrapping. Bootstrapping is nothing but if you are a three project members or four project members, and you have to need some investment, then you have to invest by yourself. Let's say any XYZ amount, equal amount, and you have to grow your business step by step. And that is a very closest method in which you are very much independent. You don't have to think for like anybody else. You have to answer anybody else. You are very independent, but you have to do it by yourself. And the business growth will be quite less, but it depends like exactly how much you invest and all that kind of thing. So this is all about the entrepreneurship, and you. So the motto for this slide. is not come into this 3P, project, proto, and prototype. But our vision, Grey Robotics vision, is that it's not big thing to start a business. You just have to think exactly what you have to do, and it's free. You don't have to pay any kind of any extra money. You already spend like 10 or 15,000 rupees in your undergraduate project. So you have to manipulate certain things, certain parameters, and you'll be entrepreneurs. You'll create some value into this real world, and that is the most important thing and most beautiful thing. That is what I have observed for this entrepreneurship thing. Revati, next, go ahead.
Okay, so now gave all the generic ideas, gave all kind of experience talks. Now we would like to give a glance of how we started with this thing, and I mean with our startup, and how we proceeded, what kind of obstacles we faced, or just a glance over our journey. So for us, the project part was very closely related to Team Robocon VIT. So we worked, me and Kunal both were a part of this team, and this is the point where we started from. We started working on various robotic projects, came across very, very real time robotic problem statements, and I would like to discuss a very successful product at our company right now is the line follower sensor. So as we all know, every engineer starts with a line follower robot. That's what even we did. And at a very good level, we are working on these sensors for the team, for Robocon competition as well as for other competitions in this domain. So we started building our projects on these sensors over there. So the next phase we came across was we went ahead and we published our work on our sensors in one of the IEEE conferences. We got our project validated. That's a very good idea to validate your project. So even if you don't want to go till patenting, try validating it with some kind of research work publication or something like that. So we could validate our project from Robocon over there as a team. So next we went to our prototyping stage. So if you can see the sensor or the printed circuit board in green color, it was our first ever prototype of our first ever product. And then we shifted on to our final product. So you on this slide, you can see the difference we exactly spoke about between your prototype and your product. So user friendly or beautifying your product or making it attractive is what exactly we were talking about, like shifting from your prototype to your product. So yeah, this is the line follower sensor, one of our very successful products right now. And yeah, happy to say that.
And yeah, I'd like to highlight one more point is that for that specific product, we receive a lot of international inquiries from countries like Brazil, Ukraine, then like all these international people we got inquiry. So that is what our success was.
So that's how close was it was for us to go from our projects to our products. So that's what our aim is, to show that how you can ideate your projects in such a way that you can take it to this level. Okay, so yeah, this is where we are right now. You can visit us, have a look at our products, and talk to us about your ideas. We are open to any kind of discussions anytime. Yeah. So today what we are doing right now, as we introduce ourselves, that we both are students, master students at universities in the United States. So we try to still stay connected, and we try to explore various opportunities here as well. So like this TC sessions is the TechCrunch series for robotics and AI. We attended the 2020 series at UC Berkeley, and this TechCrunch is one of the most renowned and most largest robotics conference in the technical domain. And this was one amazing experience. It was a collaboration of all the renowned names in the robotics domain, as well as the upcoming startups, where they threw such a big platform, such a huge platform for us to like interact with people from this domain and understand right from the research work to their actual industrial applications. So this is what we're doing right now, trying to like increase our network, spread our network, and try to build something over here as well, with all hopes of expanding our company. So yeah, we keep on attending entrepreneurship workshops and events as and when we can at our own level, and this is a very good success because you interact with so many people and you just go on increasing your network, and you understand what the market needs and what, yeah, at a very global level. So back in India, we knew what the Indian market wanted and craved for. Now we're trying to do the same thing over here, and hopefully, fingers crossed, we come up with something very exciting to share the next time we are here to talk. So what's next? So very interesting to all the young people sitting out there, to all our undergrad friends. Get in touch with us. We are looking to hire interns in the coming term or anytime you can. We are looking for December very precisely, but with all the lockdown and quarantine conditions, I guess you guys are pretty much free to start and collaborate on some very cool projects. So if you're interested and you're looking forward to work with us or share your ideas, get some advices, anything you require, we are always open for it. Yep. So very happy to share that Grey Robotics has had 3+ investor offers till now, 5+ franchisee across the country. The products have reached 25+ states. Very happy to say that we have 100+ international inquiries up till date, 500+ pieces sold for our best-selling product, and 25,000 hours plus hours of working, and we are still counting. So stay connected with us. We visit us at our website, email us, follow us, subscribe us, get connected on LinkedIn. We are all here for all kinds of advices, tech discussions, or anything you have in mind, any random stuff.
Oh,
So
video. I think you missed the
oh,
video. There's some
yeah,
videos
okay.
in between.
So I have a video, a short video on what we have been working as. So yeah.
Thank you all. Uh, we are open for
Yeah.
questions.
Thank you so much. We
So
are open for
students, if
any
you
kind
have
of
any
questions.
questions, you are feel free to ask questions to Revti as well as to Mike. You all can type the questions in the chat box.
Yeah, we have kept the chat box open, so any questions, we're up for it.
So I think it was an excellent overview of how the BE project can be actually converted into something so great. And for your information, students, I think Kunal's project was VCART. I remember testing that particular vehicle so many times uh, on the road outside. Uh, I think to get exact GPS locations or something like that. And Revti has made that bicycle which works on solar power. So they are still
It
there
was
in our
displayed at Magnetic Maharashtra. It was displayed
yes,
at Magnetic Maharashtra. Yeah.
yes. So there is a question for you.
Yeah, so we have a question, which is better for long run, IR or ultrasound or LV max? I guess Kunal, you would like to answer this question.
Yeah. So yeah, so you can differentiate sensors into the two things. One is infrared and ultrasonic or ultrasound. So in case of IR, it required IR rays, and it is more specific to the indoor environments. You cannot use infrared sensor outside environment. It is deflected by the uh, sun rays. So what you can do is that you can use ultrasonic sensor for outside environment, and it's not that deflect as compared to the infrared. So long run, for long run, you can go for like LV Max because it's an industrial grade sensor, but it's quite expensive. But if you want to run your application in more cheaper way, or just like for like project purpose, then go for like ultrasonic sensor. So there are more apart from these three, you have more different sensors available in the market. So which varies with like different specific application to application. So like there are a couple of sensors which is like capacitive sensor, inductive sensor, or like different type of sensor. Just find out exactly what your application and what your budget is, because your budget will matter a lot. So that is what answer of for your questions. So so there is nothing like pros or cons. It completely categorized into your application what you want, and depending on that you can design your system. That's it.
I would like to add, so I guess IR is something like different for a different application, and ultrasound sensors are for different application. Ultrasound sensor will always give you the distance, and IR always is used mostly as an obstacle detector. I guess it does not
Yeah, you
return the
can say
distance.
that. You can say
It's
that, but
application based. I hope
yeah,
Tanushree
but it
could
affect
answer
like
this question.
ambience affect a lot. That is my major point. Can we work with
Okay,
you with
so
the help
there
of
is one
internships
more
or any
question. It
others?
says, can we work with you with the help of internships or any other source that we can get into deep, we can learn with your great projects? You guys are always welcome to get in touch with us. We have had, in I guess summer of 2019, we have
Yeah,
had
we had a couple of interns.
we had 8 interns from VIT itself, from the Department of Electronics. Very talented students could work very well with us, could work on our products as well. So it was a good experience for us as well as for the students. So yeah, please do get in touch with us if we have any good projects which you guys would be interested in. We'll be happy to share. Okay, next question by Vishal says, hello, would it be better to use ready-made modules or we can design our own sensor module to make our system cost effective and use it? Okay, Kunal, you want to answer this?
Yeah, I will answer this one. Okay. So, so it again varies. I would like to answer this question in a different way. So, if you have less time and if you want to run your application in like couple of days, then go for a module. But if you have a lot of time in your hand, let's say if you have time like one semester, then try to make entire system on a breadboard if it is possible. Then try to make it on breadboard, learn out of that, and see if you can change that thing, some parameters, with your knowledge. Let's say if you persist any basic sensor, and that sensor has a range between like 10 centimeter to 20 centimeter infrared sensor, and if you build the same circuit on a breadboard, then you will understand, yeah, if I change the feedback register with a value from 100K to the 500K, then I can increase the distance, sensing distance between, which was like 10 to 20 centimeter, and you can change that distance to like 50 to 100 centimeters. So these kind of small things that you can learn from if you build the entire thing on a breadboard. But again, if you don't have time, then just go with like ready-made Chinese modules and just run your application. That's it. And understand the basic. Read somewhere on internet.
I would like to add to this that it all depends on your application. If people have researched so much and already created a module for it, you can
Right.
definitely use it if your time is constrained. But if you have the curiosity to understand what exactly it's doing, like I would throw a very simple example of driving a motor. You use a edge bridge IC and drive your motor by actually making the connections, or in other case you use a motor driver module where you just like use the digital pins and control your motors. So it all depends on you. It works pretty well. It's just that here you'd be having a little more of testing because you'd be doing it from scratch. And in the models,
Yeah.
it's completely tested. You have the data sheets ready. You just plug in and keep working. Also,
Yeah. I would like to add one thing with on the Revti's topic. Revti, can you just uh, close this window? It's annoying.
oh,
Screen window.
sorry.
Yeah. So I would like to add one more point to the to Revti's topic. If you are specifically go into the motor driving circuits, then if you are plan for edge bridge, then try to learn what is edge bridge and try to map entire edge bridge from ready-made IC to the actual transistors or MOSFETs or FETs or IGBTs or like all this kind of or BJTs or all these small chips, so that you will learn more about that if you have time.
Okay. So for you guys who want to get in touch with us, we have put down our email IDs. I would be putting
Oh
out
wait,
in.
wait, wait, we have one more question, I think.
Yeah, I'll address that as well. So it says, what will you suggest? Do market research first and then build product according to market, or build your product first and then do marketing? Good question, Shrey. So I'll answer this one, I guess.
Okay.
So it all depends on where you are with your product. Like, are you at the stage where you already have an idea? Or are you at a stage where you have the enthusiasm to start something of your own and then you want to go on building your idea? So if you already have an idea, wide out yourself and do a market research and then think, just go ahead with it. Like in our case, there are so many Chinese line follower sensors. There are so many branded line follower sensors. We have even marked up our price higher than these sensors, but we still get our sales. So never doubt yourself or your product idea. If you have an idea, just go with it. If not, then take a step ahead, do a market research so that you land safe. And yeah, it's quite relative. I hope I answered your question well.
Okay, I will answer the next one.
Okay.
So the next question is that for launching your startup, did you go to any startup accelerators? How did you find your investors? Okay, so there are two questions. First one is startup accelerator, and second one is how did you find your investor? So in our case, we did not go to any startup accelerator because if you go to them, then you are very restrict towards their rules, and they just you have to follow their rules. But if you do everything by yourself, then it will take time to boost, but you will be very confident about what you did and how you did, and that confidence will give you more power to increase your level from A to B. That is what I had mentioned. So that is what I will suggest you. If you are early stage startup, then do everything by yourself. No need to go to anywhere else, and no need to pay any money to anybody else, because money matters a lot for you. And second question is, how did you find your investor? We don't have investor as of now. So most of the money what we had invested, it's like less than 25,000 or 20,000 at the initial level. So after that, we had invested, we had do like recursive earning, so that whatever we earn, we invested into our company, and we did a more sales. So at this way, we somehow managed to make like more money. So that is what we did at in the early stage.
Okay, I'll add to this question. So accelerators are like, yeah, if you're talking about the accelerators we have at IITB, like the Sign Accelerator or something like that, they're a good option. Look at what you exactly need, because sometimes what happens is you work with such ideas which require heavy equipments or something like that, which you do not want to invest initially. So at that stage, it is advantageous to, like, make use of such opportunities, but unless required, do not restrict yourself to accelerators. Honest suggestion. Okay, we have one more. So according to Shay's question, we usually get problem statement from different kinds of hackathon. So we usually build the prototype initially rather than seeing the market. Okay.
Okay, that's great.
You
I'll
want
answer
to
this
take?
question.
Yeah.
Okay. Adding to stress question, we usually get problem statement from different kinds of hackathon. So we usually build the prototype initially rather than seeing the market here. So consider a scenario that so if you enter into any hackathon, so that hackathon organizer will give you a problem statement. These are the problems that you have to solve, and that hackathon people already received the same problem statement with some bigger industry. So if so, what they did is that they took a good minds from different engineering schools, giving some like basic prize money, and they took everything. They took your ideas because young minds can think in like correct direction, and they have different ideas. So you think, you give you exactly blueprint, exactly what you're gonna do, what is your entire market survey and market research and each and everything, and they will get more benefited out of that. This is the first thing that I would like to clear about the hackathon thing. And hackathon. So we usually build a prototype initially rather than seeing the market. So that is the case with the hackathon thing. But if you consider something with your engineering projects or any your personal projects, then you can make your own problem statements. And if you don't have the problem statement, no need to no need to find out any problem statement. Just do what you are doing. If you are doing anything like in our case, we have already have line follower sensors in market, but we still did it. We did it in like very more precise way, very perfect way, in more beautiful way. So in that specific way, we build something, we build some masterpiece, and we sell it. So that is what we did. So you do not need always different kind of problem statement. You can make your own problem statement, and you can proceed with that with that thing. Reddy, you want to add anything on that? On that, what is the
Uh,
scope of robotics engineering in India? Okay, Reddy, I think you should answer this question.
okay. So, scope of robotics engineering in India. If you talk about the academic part of it, so we have very less universities giving you a good degree in robotics. But I feel, so after studying 1 year over here in the United States with a very good course, I feel that robotics is very closely associated with computer science. So
Yeah,
very
and in electrical as well.
electrical as well.
Yeah,
So
because I'll highlight few things on this question, because robotics consists of like different sub branches. So I will tell you, first branch is computer vision, then AI and machine learning. Third one, which is my favorite, that is control systems. Fourth one is like natural language processing, then embedded systems, then basic electronics, power designing. So so you can you will not get a direct degree in robotics, but you can get like intermediate degree in these specific domains. I think Revti, you continue now.
yeah, so it all depends on what and how you want to study. If you're talking about an undergrad degree in robotics in India, I don't think, I mean, very close to robotics is mechatronics, what Indian universities give a degree in. If you talk about masters, I guess few universities do give robotics degree in like a master's degree. But yeah, it all depends on what domain you want to focus in. Talking about robotics engineering, scope looks a little bit less, but talk about the robotics market coming in India, a very good scope and very good companies getting along, really good and hitting the global market really well. So yeah, I hope that answered your question.
More towards robotics based things we should have to learn.
Okay,
Revti, I think you should answer this.
go ahead.
From
Okay.
electronics to
Yeah, so to move towards
robotics.
robotics, which things we should have to learn? Okay, so as I said, see, when we work on a robotics project, when we call it robotics, it includes a lot of domains like electronics, the software development behind it, the mechanical structuring behind it. So it all depends on which branch you want to focus on. In my view, a roboticist should be equipped with all of these. So my experience, I tried, like, I was from the electronics background. I had good, like, okay skill in mechanical designing, but learned a lot while building on projects. My final year project was like mechanical and electrical, so that gave me like a lot of like experience in this domain. And now I am completely focused on the software domain of robotics. So it all depends on what you want to study. If it is if you want to move towards the software development, go with the programming part, the algorithm building part, or the planning part. If you want to go with the mechanical aspects, get into the mechanical field, know the dynamics of a system, know the modeling of a system. If you want to go with the electronics part, focus on embedded, focus on controllers, processors. So
Right,
I
right,
feel
right.
robotics is everything. You be it your laptop, be it a walking robot, be it a self-driving car, everything is in the domain of robotics. So to learn robotics, you need to pick up your domain and be very specific to it, because this is what the market needs right now. You need to be very focused on what you want and not be like, okay, I'm going to be into the software domain. Software has a hell lot of things. Decide where you want to get into. But for undergrads, yes, I think you should have a glimpse of all the three major fields and then
Yeah.
get into. Yeah.
Yeah, so I would like to add more things on this answer because I'm from electrical background, electrical masters, and my focus is more towards robotics. So while doing that, I had a like good experience. What I can correlate with what I have learned in VIT. So the main thing is that you have to learn, and you should know all the basic concepts of electronics, basic electronics, BEE. Everybody learn that. Then you must know the control systems, all body plot, root locus, and all these kind of things. You have to learn different controllers because what we had learned in undergrad, it's just like 5% of control system. There are many more is to learn. So these are the different things, theories, different theses that people use in robotics with respect to the controls. And in case of computer science domain, there are a couple of subjects that I have learned, like computer vision and AI, machine learning. So these are the things which provides intelligence or autonomy to your robot, and control provide a control system. These provide autonomy, and so you have to synchronize everything with each other. If you good at software, but if you don't know anything about control system, if you don't know how to run a simple DC motor, then there is no then there is no use of this then your knowledge. Then you should know all these things, like all these triangle robotics control, like electrical, computers, and mechanical. And you will learn more when you start building your own robots and try to make it more autonomous on a basis of vision, different sensors, IR sensors, ultrasonic sensors, IMU. So just use that sensors and just try to explore more, try to make a robot more intelligent and autonomous. That is the most important thing.
I think we're done with the questions.
I think we are done with
Yes.
this with the question.
Okay. We would
Thank you
really
everyone.
like to appreciate. Yes, it is a very good initiative by our department. Very proud, and we really
Yeah.
thank our HOD and Anil sir for having this on board and having us over here, giving us an opportunity to talk about our experiences. So while preparing this presentation, we walked through all the lanes we had, like all our experiences. It was really great. So we are really grateful. Hope we could help everyone in some way or the other. Stay in touch and approach us anytime you wish to.
Yeah.
Yes,
So that,
that
and
means we
mostly
should.
in a month of December, I'd like to mention one more
Yeah,
thing.
yeah.
In a month of December, we are planning to come to the India. So mostly, if anybody is interested, and we can meet, we can discuss more thing on this
We
robotics
can
work.
surely have a meetup and
Yeah, yeah, yeah.
talk more on.
So let us know. Thank you, sir.
Yeah. So let me officially
Great.
conclude this particular webinar. If there are some questions, I think you have already given our students your email ID, so question answering can move forward. Even internship opportunities can move forward. And once you are in India by December, probably we could have one session on campus itself, uh, subject to
Great.
lockdown conditions. And so thank you everybody. I would like to thank Dr. Anjali and Professor Rajeshri for helping me out to conduct this particular webinar. And most importantly, to Revati and Kunal for staying up so late in the night and giving a webinar. I mean, you look as if you have just woken up and you are so fresh during giving the webinar. So I really appreciate that, and
Thank
thank
you,
you
sir.
very much again. Okay,
Thank
so
you.
Thank you.
all participants are now free to log out. Bye bye.
Thank you. Bye.
Bye. Bye. Bye. Bye. Bye.